So let me start the presentation. So what is Git? Git is basically a distributed version control system, and the way it works on tag is our repo is actually SVN. You can think of it sort of like a backend, and we have like Git installed in our local system, and basically it interfaces with SVN. In two ways. One, it will read. Basically, whenever your local source code you want to sync with our repo, you read it. And then when you actually submitted a code after a code review, it basically you write to the SVN repo. And then with the Git, everything actually are stored locally. So what's the difference between Git and SVN? I'm sure like there's still a number of you guys are still using SVN. Basically, the advantage of Git is that Git clone actually gives you a complete copy of the entire history of that project in your local system. So you don't have to keep fetching from the repo. You have all the information you need when you use Git. And because all the things are stored locally, actually every operation is actually pretty fast, and you can actually do it offline. Another advantage is that there's no single point of failure, because like if you imagine when you're using SVN, you pretty much rely on the SVN server. If it's ever going to go down, you pretty much could not do your work. Whereas for Git, everything is copied locally, and you still have that intact. You actually have a backup of the entire project, and it also doesn't depend on one centralized server. You can actually integrate to have like multiple remote repository to your project. So those are the advantage of Git. That's why we actually encourage you guys to actually use it for those who are not yet adopting it yet. So before I start, let me start with some basic concept on Git. Basically, for Git, there's three main states. Okay, there's the head, which is the last commit snapshot. Is basically your local repo, if you can think of it that way. It's things that you store before you actually push to the SVN repo. And then there is an index. Index is actually the things that you propose to commit just before you commit. And then you have the working directory. Basically, if you start to modify your file, is whatever changes actually goes into the working directory. And then you have command to move between stages, which I will illustrate later. But always bear these three main states in mind whenever I go through the description. So the way I format my presentation is, is following the flow that you would normally work with. For example, if you get a bug, you're trying to fix a bug and so forth, rather than just dumping out a list of command and then you have to, as out of order. So I try to format in such a way that it just go with the flow of normally how you would use it. So let's start with the installation. Basically, I have three different operating systems. If you have Linux, basically just sudo apt-get install git core. And then for those who are using Mac, I have a link here, which I'm going to share out the slide so that you can actually click the link here and then install wherever it needed for your system. And then for Windows 7, you need to install Cygwin, which mimics the Linux environment, and then kind of enable packages that has like Git as a prefix, SVN as a prefix, Perl, Python, wget packages. The star just means the wildcard. Basically, install those packages when you install Cygwin. And then for configuration, basically you open a terminal and then create a file called in your home directory, create a file called .gitconfig. And then the content of the file, basically you can copy off the configuration that I have here. But feel free to add stuff or modify stuff if you know what you're doing. Basically, for this, obviously you're going to replace the name with your own name and the email with your own email, and so forth. Okay. Next, I'm going to talk about is the review board setup. So basically, this actually automates the code that needs to be reviewed. Basically, if you set this up, you can just issue a command, and then it will basically automatically generate a diff and then send that diff to review board, so that there's less work on your end. Later on you just need to go to review board and fill in the reviewer name and description, and then you're done. You don't have to generate diff and then actually upload to review board. It's all done automatically for you. So let's start with some basic command when you start to use it. Basically, git SVN clone with the repo URL and the target directory. So this basically clones the repository from the SVN backend to your local machine. One thing about this is it can be very slow, especially if you're in Beijing. It's even much slower. So there's actually another way where we can. It's more efficient. And also, just like to note, git SVN init and git SVN fetch has resume capability. If you were syncing, at some point in the middle you stop and then you issue this command, it can actually start from where you left off. Okay, so another way to get a repo is, or a faster way to get a repo is actually to copy from a colleague that already have the Git. And then all you need to do is just copy the whole source directory to your own local machine, and then basically sync to the repo after that. This is much faster because it doesn't need to fetch everything from SVN. Everything you have is locally. You just need to update a little bit based on the latest change file. And this is the command to use to actually sync your local repo with the latest in the SVN. It's called git SVN rebase. Okay, so after you got your source code, everything ready to go, then let's say you receive a bug, and normally what we do in this case, we will create a branch so that we can do whatever with the branch, and you can create a unlimited number of branch. And the command to do that is actually git br is the abbreviation for branch, and then you give it a branch name. Just like the example I show here, you git br new branch. And then if you don't actually give any argument, it will just show what current branch you have, below. I'll have a demo later. And then once we create a branch, we want to switch to that branch. And the way we do that is using checkout. CO is actually abbreviation for checkout. So if I do git CO new branch, I actually switch to the new branch. And the star in the output actually shows you which branch you're currently at. That's a combo command which you can use. You don't have to just, instead of doing create new branch and then switch to new branch, you can actually do git co-b and then the name of a new branch. That actually combines the two commands, create a branch and then also switch to the new branch. And then we have what is called a git add. And this is basically a command to actually switch between stage. Remember I told you that the three main state. So whenever you start modifying a source code, it goes to a working directory. So your whatever changes you have is a working directory until you issue this command git add. Once you issue git add followed by the file name, it basically moves whatever is in your working directory to the index, which is the second stage, which is the state that you're going to commit later. And obviously when there's add, there's also remove. It's basically the same thing, but you just remove file that you do not need. And then also there's a moving file, which is MV, abbreviation for move. You can move whatever file name to another file location. Okay, this is pretty useful. So Git ST, which is a short form for status, basically it gives you a sense of what has changed and what what stage of each file is at. For example, if you have one file at the index, and one file is still in the working directory, it will show you the list of all the file that you have changed in that branch. And then we also have reset. Reset basically is if you are trying to, if you made a mistake or you're trying to revert certain things, you use git reset. And the way you use it is if you issue git reset -- solve, and then followed by a commit ID, you basically just move your head, the first state, to wherever your commit ID is. And then if you don't issue any optional argument, it basically moves both the head and the index to the commit ID. And then if you really want to move all three states into a certain commit ID, you basically issue git reset -- hard. And then if you don't supply any commit ID, by default it thinks it is head. So more example of how you can revert certain things. Basically, in this case, you can actually always check out a version of a file. For example, one very useful example is if you start modifying a file, and you decide that, oh, I made a mistake. I don't want to actually modify the file. I want to revert back to the original state. You can, or to any other version of it. You can actually do git co, followed by the commit ID, which can be head if you don't want to modify it, and then followed by the file name. This would overwrite or essentially unmodify what you have modified, the file. And if you can also do it through like git co -- file name and path. And the path is basically recursively. So let's say if you have like a lot of changes in your working directory, you can actually just specify the current root directory and then -- dot, and basically that will revert everything that you've done on the working directory. And then we also have git reset head followed by the file name. So this basically unstages a file. What that means is staging a file means that it's in the index state, which is the second state, and then unstage means it move it back to working directory. So whatever file that you have changed and you have moved to index, and you find that, oh, I made a mistake. I don't want to go there, and then you can move it back to working directory by issuing this command git reset head followed by the file name. Git revert is an interesting concept. It basically, what that does is after you committed something, and on the local repo, which is on the head side, and then you want to revert that change, basically you call git revert head, and what that does is it actually creates another new commit that reverts what you have committed. So basically, you neutralize, cancel what you committed previously. This is ignoring files. So ignoring files is a situation where you have certain file in your local directory that you want Git to ignore. Otherwise, it can be very annoying. You see like files that are on track, but you don't want those files to be involved. You can actually do that by going to your home directory, create a file name called .git ignore, and then just basically, in that file, just list out the full path of the file names, or even a path that you wanted to Git to ignore, and it will not include it. And basically, after that, just issue a command called git config -- global call .exclude file, and then basically the path to your git ignore file. And then you see in your git, it will just ignore those. Okay, stashing. Sometimes you'll find that the git doesn't allow you to switch between branches when you still have things in the working directory that you actually haven't committed the change. Or maybe you just decided you don't want to commit, but you want to make another changes. Stashing basically allows you to save all your current changes temporarily. It just temporarily store it in the memory. So basically, what you do is if you issue git sta, which is short form for stash, and then save followed by a name identifier, it basically store all your changes into that name identifier, which you can recall later on. So if you issue git stash list, it will list out all the identifier name that you have saved. And then you can recall it by issuing a git stash apply, and then followed by stash alias, curly bracket, followed by the end number in the list. That would dump out what you have saved before. Okay, so after you know how to create a branch, you modify your file, you move it to index stage. Now you probably are ready to actually commit to the local repo. And there's several commands for that. I mean, pretty much it's git CI, which is committing your change. If you put a -a, basically it will commit everything to your local repo, which means that your working directory plus the index. If you don't supply the -a argument, basically it will just commit the index to the local repo. And just like SVN, there's also a -m where you can actually put in your commit message. And so git CI -amend is if you find that you just committed something you wanted to change, you can still do that by just issuing git commit -amend. And I'll show you later on an example. Let's say if you wanted to know what is the difference between the changes between working directory and index or index we had, you can actually do git diff. This allows it actually shows you the code change between the working directory as well as the index. And then if you want to compare the index and the head, you can just issue a argument called --cache. And then if after you committed everything, you want to you want to see the difference between different branches, you can also do so by just issuing git diff and then the corresponding branches that you want to compare. Okay, this command I find is very useful. So in the repo you might have several commits, and you want to look at the history of it. You want to find out more about things which commit before your commit, or even look at your previous commit. You can issue called git log. LG is a short form for log. And then if you just type git log, it will just show you all the previous commit. And then if you want to see the code diff as well, you can do git log -p. That will show you the code diff. If you don't want to see all of it, you just want to see the last two, you just basically dash whatever number you want, -2. -pretty equals one line basically is pretty useful because it displays everything in a compact way. You can see that the TA bug number and the description without looking at too much of a detail. And then we also have like a timeline. You can actually do git since 2 weeks or a certain date or until which date, or you can also search for like a specific author or committer. So I find that very useful, especially when you're tracing through the changes that was made previously. And then the commit ID is basically when you list out git LG, you will see like, I'll show you what is the commit ID. It's basically a very long number. And then if you put like git show and then followed by the git followed by the commit ID, it will show you all that code diff for that particular commit ID. Okay, merging, basically just merge the branch name to merge the code change on a branch to the current branch. And this interactive mode is pretty interesting. Basically, it allows you to interact while changing what you wanted to change. Basically, how you do that is you do a git rebase -i, which is stand for interactive, and then that allows you, like, if I put head, tell the number of commit involved. For example, one very useful example is squashing several commit into one. And then, if I want to squash like 3 commits into one, I will say head tilde 3 means, the last 3 commit, I want to play with it. And these are the description. Once you issue that command, you will see that P is for pick, R is for revert, E is for edit, S is for squash, F is fix up, executable. So I haven't played a lot with it. I just play with squash, and I'll show you how we can use this later to actually squash the commits. Oh, in fact, it's here as well. So basically, when you issue the command, you see like, pick a certain ID, and then it have like a description of the bug. And then basically, what you do is you just change the pick into like the alphabet that was mentioned previously. Like squash will be S, and then you just basically save it, and it will basically squash the commit. So one thing which you could, I guess this example, I was just trying to show 2 ways you can achieve by by achieving the same thing. Basically, this is just let's say if you do a commit and then you made a mistake, you want to revert the file that was committed. You can either git co master file name, basically undo all the changes for that file, and then you can commit that file and then squash the 2 commit into one, so that it actually removes the modified file in your commit. Or there's another easier way, which is to actually use git commit --amend instead of using the squash. But just to show you, that's actually in Git, there's actually many ways to achieve the same thing. So following the flow, so now that you already can see the diff, you can see your code changes, you can see what file is changed. So now maybe it's time you want to create a patch. A patch could be, you want somebody to review your code changes informally, or you want, basically just look at the difference in code. You can do git format patch followed by the commit ID, and then the number of commits that you want to generate. It can, or if you want the traditional way, you can actually do git rb-diff and then give it a file name. Basically, it will generate like what you are used to, the SVN diff followed by a patch diff. And then this is basically just applying the patch, git apply diff file. So if you set up accordingly, so now you are actually ready for a code review, and then basically you just issue post-review. And this is what I mean by it's actually automated. Once you issue this command, it will take your latest check-in, and it will basically package into a diff and then send it to review board. And then after people has sent comment and you modify the code, you actually can update the same review board code review by issuing a -r and the revision number, so that it doesn't create another new one. It actually update the existing one that you have. And then, if you pass the code review, then obviously the last thing to do is to submit to our backend SVN repo. And then this is done through git SVN decommit. And then after you finish all of that, basically you can delete your branch. You're done with it. So you can do git br dash capital D and then the new branch. But you cannot remove the branch while you are in the branch. So you have to actually go to another branch to actually delete whatever branch you want to delete. So, and then there's a very helpful, if you cannot remember all the commands or need more help, you can actually type git help. And then if you type git help without the command, it will show you a list of available command. And then you can actually type git help and followed by the command name to know, specifically what arguments there are for that particular command, and it will have description. So the thing that I encounter while helping people to set up Git, there's a few things. One is, the faster way of actually getting the repo. I've encountered like people having, after doing that, I encounter people actually have a lot of lists of file changes which they didn't modify. And the resolution for that, you can do a git reset -- hard. Basically, it moves all the tree state into the latest. So that actually solved the problem. And then for Windows 7 user particularly, I've seen like a call stack crash stating something like a remap error when you do a git SVN rebase. And the way to fix that is actually close out all the SIGWin window and then basically go to the SIGWin bin directory and issue this command and then restart. It should be fine after that. So as what Nate mentioned, we really encourage people to use Git. So we are offering a one-time limited time offer for the whole next week. If you are interested to convert to Git, please send either me or Nate email, and we will actually spend time sitting down with you and to help you guys set up. So it's just limited to next week. So yeah, and that I conclude my presentation. Oh, actually, I have a demo. Yeah. All right. So okay. Let's see. Okay. So I know you probably couldn't remember all the command, but basically BR is branch. So as you can see at the bottom, you see like a master, and then beside the master there's a star. So let's say if I receive a bug, I want to make some changes. Basically, I can issue a git checkout -b, which is the combo command. I can create a. Oh, actually, let me. Oh, that's fine. Okay, now if I type git branch again, you can see I have created a branch named test, and then it has switched to the new branch, and then now I can basically start to modify file. Right. Okay, so I've modified this file. Now I want to see, what have I changed so far, and I can do git st, which is status. So you can see that the red line actually shows the working directory. Remember the tree state I was talking about? It actually shows in the working directory what I have changed. And then if I wanted to move that, I will use git add. And then you see the difference. Now it has turned into green. So that the green is actually the second stage, which is the index. And obviously, you can continue to modify the file, and then what you will see here is there's a red and green, meaning that I changed my working directory portion, but I also have another copy which is in the index. And let's see what else. Yeah, so on the stashing part, if you wanted to start to save things, you could by doing git stash save temp. Okay, basically it saves everything. You can see right now it doesn't have anything. You have stored everything in the temporary location. And then I can also call it back out to see, okay, I only have one item. Now, if I want to retrieve it, I can do stash apply, and then followed by stash alias curly bracket 0, which is the only element there. And then I recall it back out. What else? So let me demonstrate the commit thing. So let me add this first. There's something wrong. Okay. Did I do? Oh, okay. Oh, doesn't matter. Okay, so now if I can do just commit CI, which will just commit the one that is in the index, and then as usual you will have to enter whatever TA bug number you have, and then escape and then quit, and then now you have committed the change which is in the index, so whatever is in your working directory is still there, and then now. For example, you want to look at what you have committed so that you know what it is. You can do git lg, which pretty much this brings up a lot of the previous check-in as well. The check-in that I checked in is on the top, which is the head, as you can see, TA002. Now, if I wanted more information and I'm not interested in the other, I could do git lg and then just -1, which is just mine. And if I wanted to see the code different, I can put a -p, and then you can see, it only basically have mine, and then I can see the code. And then, but what if I wanted to just see, say only mine? I can do author equals to, and it will only shows things which are committed by me, and not anyone else. And I can also do like the time-wise, and do -- since equals to, I can do 2011 -0 10 and then 25. So it should only show me since October 25th. So this are the way you could use to kind of to kind of like look at what are all the different commits. And let's try the squashing portion. For that, I need to have another commit. So I'm going to look at probably tag, then just vim. Okay, and then enter there mode, whatever. Okay, let's look at what we have right now, and then I could git add app. Okay, look at what I have. Git CN again. and then followed by I. Okay. And then now I should have 2 commit in the local repo. And then I can do by, let me just do 3 so that I can see one which is not done by me. So you can see there's test and test2. So let's say now you wanted to actually squash the 2 into 1. You don't actually have to have 2 commit. What you do is you do git rebase interactive, and then basically you put head, which is because it's the top 2, and then tilde 2. So that basically select from the head to 2. Oh man, okay. First you need to stash. Okay, so as you can see now, there's 2 pick, and I'm just going to squash. So by putting S, it will combine the 2 into 1. And then I'll escape, write it. And I can also do that for the comment. So maybe I don't need this comment anymore. I kind of just comment it out. So all that commit would have this comment. And then, yeah. So now if we look at the, as you can see, there's only 1 now. Yeah, so that's the use of squashing. And obviously you can also do like an amendment, the previous method I mentioned, which is git commit dash. Oh, okay. No. Well, I want to show them post review. Okay, let me just quickly show you. So if I tap post review, and you can see that it's actually posted, and the revision number is 8697. So if you go to the review board, you will see. Okay, never mind. Trust me, it works. I'll sit down with you guys if you guys need assistance for it.